Hello, my name is Sagar Vaidya. Here is my here's my Lab 11 temperature effects on beam vibration for ME 2004. So the objectives of this lab are similar to Lab 3, the lab I based this upon. But I added a different procedure that had to do with materials and material science engineering. It was one of my favorite classes, and I thought that the fact that we didn't get a lab regarding that class was kind of sad. So that's why I took this more material science route. So I added in objectives to understand how temperature affects certain materials, specifically metals and plastics, to turn strain gauge data into stress strain charts and compare experimental data to predetermined material values, i.e. the Young's modulus, the yield strength, a fracture point, etc. Um, Also to perform a free vibration experimental measurement of cantilever beam. So the rest of the objectives are from Lab 3 directly. To use strain gauge to specifically measure dynamic tip displacement, to measure dynamic tip displacement for comparison theory, and perform a spectrum analysis of the time-dependent tip displacement to determine the natural frequencies of a cantilever beam. So a lot of the theoretical topics included with my lab 11 were elastic and plastic strain, ductility, and other similar characteristics for materials, and of course cantilever beam theory that we saw in lab 3. So the materials I would add to this lab would be these on the top there, the plastic rulers, so rigid plastic rulers that don't have a lot of bend to them, along with the metal rulers that we already have in the lab, made out of one piece of metal, and then also these pliable rulers that are also plastic. In my lab description, I described them as flexible, and then the rigid plastic rulers as non-flexible. So the procedure itself is similar to Lab 3, but we are adding components of Lab 4 specifically, like the heater and the heat flux sensor and the thermocouple. One thing I'd want to add is controlling the heater temperature. I want the heater to be able to go as high as it could. You could also add in more cases than I did, where you have heat at the middle temperature, heat at a low temperature, and then heat at a very high temperature to compare how the levels of heat affect these material characteristics that we're trying to find. Um, so essentially, the first initial part of it is similar to the first 7 steps are similar to lab 3, where essentially starting with a beam at deflection of 0, and then you are gathering data as you put weight onto the beam. However, this time we'd want to put such high weight on the beam that it would cause plastic deflection within each material. So for metal, we're going to have deflection, for plastic deflection, and also the flexible ruler as close as you can get for deflection for that one because it is just so flexible. Um, then the student would get a new ruler and add in the temperature modifying element. So we have the heater that we use in lab 4. For the heater will be used for the metal ruler as well as the plastic rigid ruler or the non-flexible one. For the flexible plastic ruler, the temperature, the way we're modifying the temperature is putting it in the freezer and cooling it and seeing how that affects the material characteristics. The overall goal for the lab would be to, of course, do the data processing like we did in Lab 3. However, we're adding the element of developing stress strain curves, specifically the one that I showed to the right here. This is a really good example that I liked. And evaluating the material and finding specific values found in the curve. I did make a note that in the lab manual that the plastic non-flexible ruler, we'd want it to go to the fracture point because due to the weight, and I think that'd be a really good experiment just to have. Um, I would also have, I also had in my Lab 11 manual comparing theoretical data to experimental data. And I noted that as part of the pre-lab for this, you would probably have students um, find theoretical data online for each of the specific materials and then create the chart from that just to do some like additional research before the lab is conducted. Thank you so much.